Back to the bell work. We have a diagonal that's 9 in square root of 9 times square root of 2. We had to notice that this was a 45. We didn't really have to notice because I pointed it out. 45, 90-degree triangle. Which, if we remember, this dealt with s's. And that meant that this side was the same as this side. And our hypotenuse was s square root of 2. Well, if this is true, and this turns out it's 9 square root of 2, our s actually equals 9. So s equals 9, so this equals 9. This equals 9. And we're just going to have area. I don't know why I put that s equals 9 there. It kind of gets in my way. But we'll say area equals length times width, which equals 9 times 9, which equals 81. Length times width, 9 times 9, 81. Done. But you had another 45. You could have solved this a different way. You could have said that both of these are the exact same, and you could have did like s squared plus s squared equals 9 squared of 2 squared, but then it's a whole bunch of extra work. This is the easier of the two methods. Okay, our next one says I have a rectangle with base 12 and a diagonal of 13. So we get a rectangle down, boom, boom. We draw a diagonal. We have a base of 12. I got a diagonal of 13. That creates a right triangle where I need to figure out what x is. Okay, so that means that I'll have 13 squared equals 12 squared plus x squared, which is going to be 169 equals 144 plus x squared. Subtract 144 from both sides, and you're going to come up with 25 equals x squared. Square root of both sides, and we'll come up with x equals 5. That is not my answer, because we still have to find our area. Maybe I'll put it here. Area equals 5 times 12, which equals 60. 60 is my answer. All right, questions on either one of those two? Okay, we're just going to continue on to this lesson. If you have questions on the homework, we'll just do them individually after. That'll give other people some time, because we only have like 10 minutes to do homework, so I'll give them a little extra time. Okay, the first thing we're going to talk about is area of a parallelogram. The cool thing about parallelograms is I just have to redraw it, and everyone will know how to find the area of it. And what I do to redraw it, all I'm going to do is I'm going to slice this guy off. All right, this is like a dead toe. I'm going to slice it off.
Ew.
What? It's a dead toe. How is that gross?
That's not a thing.
Sure, sure.
Ew. Ow.
Picture it. It's like dying, so it turned black. No, I'm just kidding. I'm not going to turn it black. And we're going to transplant that toe on the other side of the foot.
You know, like kids passing out in your class.
So we're going to transplant that guy to the other side of the foot.
Okay.
Oh, it's a rectangle.
And what does that look like? What does my new foot look like?
Oh my god.
Well, it's not a real foot.
My feet are already gross enough. Sorry.
So Madison already said it. It becomes a rectangle. And how do I find the area of a rectangle? Yep, base times height, length times width, whatever. All I'm looking for is PQ and this height right here. So I just need to find this line right here. So note, this looks just like same area as a rectangle. Same area as a rectangle. We're just going to change. So rectangle, we use length and width. For this one, just like Madison's saying, I'm going to use this as my base. This right here is my height. So this distance here is going to be our height. So to find the area of a parallelogram, rather than length times width, it's just going to be base times height. So area equals base times height. Another way to put that is just area equals b times h, base times height. However you want to write it, it's fine with me. Base times height, that's it. Works just like a rectangle. Once you cut off that toe and put it on the other side.
No. Oh.
You just don't picture a toe, it's easy.
Oh. Oh.
This is on you for picturing
Every
it.
time I see a triangle, I'll be like,
Nope, parallelogram. Oh yeah, triangle's just the toes of the parallelogram. Okay, so we're supposed to find the area of the parallelogram shown. So that means for a parallelogram, I need to know the base and I need to know the height. For this one, I know the base. My base equals 10. I just don't know the height yet. However, I do know that that's a 45, 45, 90 degree triangle. So just like our bell work, let's just note that this must be 45 because this is 90. From our bell work, that must mean that the two sides are our s's. So s equals h. And our hypotenuse is going to be our s square root of 2. Alright, so that 8 is going to be how I get to my s, and also gets me to my height. So we're going to say s square root of 2 equals 8, and that will give me my s. By just dividing both sides by square root of 2, we'll come up with s equals 8 square root of 2. However, we have to go a little bit further. What is wrong with saying 8 square root of 2? What is not allowed in that? Yeah. I can't have a square root in the denominator. You did not sound excited by that, though. Oh, yeah, it's Monday. Okay, so we're going to multiply the top and bottom, or our numerator and denominator, by square root of 2. Ooh, that's pretty tiny. I should have wrote bigger. Can you guys see that, Jack? Can you see that?
Yeah.
You sure? You're not just saying that so I don't like rewrite it or something? Okay. So you should have 8 square root of 2 over square root of 2 times square root of 2 is just 2, which equals 4 square root of 2. I started making it bigger as I went along. So s equals h. So in fact our h equals 4 square root of 2. That means I know my base and I know my height. So all we need to do is, I'm going to put a little divider here so I don't, I'll just put my area in that little area. So area equals not half. It just equals base times height. Our base here is 10. Our height was that 4 square root of 2. So that's just going to equal 40 square root of 2. So our goal is just to get our height and our base whenever we have a parallelogram. The only reason why I did that next one, is because your base and your height might look a bit different. Your base may not be the bottom. All right, it's just saying it's the bottom of my height. So if you look at that trapezoid, not the trapezoid, parallelogram that we have, we could think of that 6 as being our base. All right, which would make that 8 my height. All right, so as soon as you know your height, you know which one is referencing your base. Your base is going to be the one that connects to your height. Okay, so just like me turning like this, that makes 6 my base, 8 my height, and I don't have to do any additional work. So you don't have to find this just because I put it on the bottom. As long as you have something that's connected to the height, you're good. What's Mike doing? Okay, so our area, once again, equals our base times our height. Where our base on this one is 6, our height is 8. So that's going to equal 48. Are we good on parallelograms? Minus the toe? Okay, then we're going to talk about triangles. Triangles are pretty easy because we already pretty much covered them. If we look at our bell work, we will notice that we can divide a rectangle into two triangles. And note, if I divide a rectangle into two triangles, I'm dividing its area in half. So that triangle, let's go ahead and look at our bell work. This triangle is half the area of the rectangle. Now the rectangle is base times height, so that must mean that a triangle is half of that base times that height. And in fact, that is the area of a triangle. It's just the same thing as our rectangle, except we half it, because we're taking half it for that triangle. So we go back here, and so we're taking half the area of a rectangle. So that means our area is going to equal half our base times our height. And a much easier way to write that is just half. Half of your base, your b, times your h. Half of b times h. So if we notice, everything so far we covered is base times height. The only difference is triangle is half of base times height. So base times height is really big in a bunch of these. Okay, we're supposed to find the area of both of these triangles. I'm going to go ahead and cut that guy in half because we actually have two problems there. So let's just find the area of a triangle with sides 8, 8, and 6. So let's go ahead and draw a triangle. And we'll call that 8, 8, and 6. So it's an isosceles triangle. I need to know the base, which I know the base is 6. I just need to also know the height. All right, that is my h. Well, since it's an isosceles triangle, this is, since it's a height, it's a right angle. So we know that's right. And because it's isosceles, it actually cuts that 6 in half. Bless you. So this half is 3. This half is 3. Maybe I'll put that in green. So that's 3. And that's 3. I already know my base is 6. Just need to solve for that h. To get that h, we're going to note that we have a right triangle with 3 and 8. So to get that h, all we need to do is h squared plus 3 squared equals 8 squared. So we're going to go ahead and do that to get our h. So we have h squared plus 3 squared equals 8 squared. A squared plus b squared equals c squared. That's going to be h squared plus 9 equals 64. That means that h squared equals 55, which means that h equals the square root of 55. And that's fully simplified. All right, h equals the square root of 55. Now to find our area. Now to find our area, we're just going to say area equals half our base times our height. Well, that's just going to equal half. Our base is going to be 6. Our height is square root of 55. I don't need a calculator because I just say half of 6 is 3. And we have 3 times the square root of 55. And we're done. Our next one's pretty easy. It's just another way to find our height. Okay? Once again, I'm just trying to give you examples of how you can see different elements in it. So on this one, our height ran right through the middle. It created that right angle. In order for it to be a height, it's got to be an altitude, so it has to create a right angle. Well, if you remember from obtuse, I couldn't make a right angle unless I would extend this base and drop a perpendicular like that. even though this is outside of the triangle, this 15 centimeters is still our height. So this is still our height. And to be a height, all it has to go is from the vertex and make a right angle on the bottom. Meets both those criteria, so this is our height of our triangle. So that means half our base times our height, our area, is going to equal half our base, which is 22, times our height, which is 15. That's going to equal 11 times 15, so that's going to be 165. Yep, centimeters squared, because they actually gave us centimeters, so I'm going to call it centimeters squared. Yeah.
What if you don't get an isosceles triangle? I feel like
For this one, there's no way to solve it. So if this would have been 8, 6, and 2 or something, unless it happens to fall into one of those, perfect square triangle things where we know the angles.
oh, like that.
Yeah, but that's not going to happen. If I give you a problem like this, it's either going to be isosceles or it's going to be equilateral. Otherwise, I'll give you a little bit more information. I might say, hey, and that's 45 degrees or something. Okay, you need that extra bit of information. Good question, though. Okay, so we just have one more problem with triangles, and that is the fact that you might not always be looking for the area. They might give you the area and you have to find something else. And this one, they give me the area is 60. They say it's 60 centimeters squared. And they said I'm supposed to find the height. Well, we're just going to plug it into the equation. Our equation stays the same in the fact that area equals 1/2 our base times our height. It's just the information we can plug in changes. Our area now is 60. And that's going to equal 1/2. My base? Well, my base is going to be 8. Because remember, our base is the one that's connected to our height. So that means this must be the one that's the right angle to the height is our base. So this one is not our base. We wouldn't need this information. But this is going to be our base. And then we have by h. Well, that means 60 equals half of 8 is 4 times h. Divide both sides by 4, and we have our height is going to equal 15. Our height is going to equal 15. All right, there's just one more area to go through today. Then we'll be done with areas for this part. We got a little bit more in a different chapter, but for today. And that's a rhombus. Area of a rhombus. The first thing I need to do is draw a rhombus. So I'm going to go ahead and draw a rhombus in here. I'm going to try not to make it look like a square, even though squares are a rhombus. I'm just trying to, that does not look good yet. Or ever. Just go back. Just go back. I'm trying to erase stuff. And the important thing about a rhombus are all 4 of our sides are congruent. For this rhombus, we're going to put diagonals in because we have to know the diagonals of a rhombus. And if we notice, we create a whole bunch of triangles. All right, we're not going to go through how this formula comes to be. Just know it comes because it's all those triangles. All right, and we need to know 2 bits of information from a rhombus. We need to know the diagonal 1, so I'm going to call that D1. D1. And we need to know diagonal 2. I also want to rehash that if this is 2, this is 2, so the whole diagonal is 4. All right, so I might just give you this bit and say this is 3. You have to know that the full diagonal is 6. It's twice whatever this little section is. Okay, so the area of a rhombus, the area is going to equal half of diagonal 1 times diagonal 2. And that's it. It's just diagonal 1 times diagonal 2 and half that. Okay, let's go ahead and apply it, and then we'll be done and we'll be working on our homework. All right, so we're supposed to find the area of this rhombus. Well, let's just go ahead and say I know one of the diagonals. I know diagonal 1 equals 4 plus 4, it's 8. Right, this whole diagonal here is 8. I just need to get this other diagonal. And to do that, I'm just going to note that these create a right angle where they intersect. So that creates a right triangle. I'm going to go ahead and write that right triangle that's right there. Maybe I'll color it in purple. So I'm looking at that right triangle right there. Okay, I am going to redraw it down here. Where this is my right, this is 4, this is 5. Once again, I have a right triangle where I know two sides, so I can just use the Pythagorean theorem. And let's go ahead and call that missing side x. So that's going to give me x squared plus 4 squared equals 5 squared. That's x squared plus 16 equals 25. That gives me x squared equals 25 minus 16, which is 9er. So x equals 3, because we take the square root of both sides. That means this is 3. This is 3, which means my diagonal 2 is going to be 6. All right. Well, easy enough. Our area is now 1/2 diagonal 1, which is 8. I should put an equal sign, not a colon. Times 6, which is going to equal half of 8 is 4. 4 times 6 is 24. My area is 24. That's all there is to a rhombus. So the rhombus is the only new one. All the other ones use base times height. Triangle used half of base times height. Parallelogram used just regular base times height. Squares and rectangles just base times height. Alright. Also remember, this is kind of offshoot. A square is a rectangle and it's also a rhombus. So you could apply either one to a square. So if you know both diagonals of a square, you can use the rhombus formula. If you know the length and width, just use the rectangle, the length and width. Alright, go ahead and get started. I think it's numbers 1 through 12. I forget what page it's on. I kind of cut it off there. What page is it on? 431, 1 through 12. We're going to be working on this little section for the next 3 days. So tomorrow we're going to do more problems, and then we're going to do a worksheet on it. Because this is some important information that you need to know. You need to know how to find the area of these three things.